Hi folks, I ANKIT PAREKH welcome you to this video lecture. In our previous lecture, we were discussing about trigonometry. This is the sessions for basic mathematics used in physics. So today we are going to start derivatives, or you can call it differentiation too. These are very important for the concepts which you are going to use in various chapters. So let us start with this derivative. Derivative is basically rate of change. Okay, it could be average or instantaneous. See, let us understand with an example, very easy example, say velocity, or you can say speed. Suppose a person starts from A and moving towards B. Okay, at A its speed is 0, then on its vehicle he increases the speed, gradually the speed is increasing, and then finally reaching to the end and stops over here B. Again speed is 0. Suppose this distance AB is say 40 kilometer and time taken by the person to cover this distance is say 1 hour. Okay, this is distance, this is time. Obviously speed is equals to distance upon time. So we can say speed is equals to distance upon time. Where distance is 40 kilometer upon 1 hour. So 40 kilometer per hour. This is the average speed for the person, right? Or you can say rate of change of distance with respect to time. Okay, here distance is covered by the object, rate of change of position I should say. Initial position is A, final position is B. Distance covered by the object is 40 kilometer with respect to time. That is your rate of change. Okay, let us talk about instantaneous speed. What instantaneous speed is? Throughout the path, 40 km per hour is not a constant speed. Initially his speed is 0, then increasing, then decreasing, then increasing somewhere, or continuously increasing. Then at point B he applies, before B he applies brake, speed is decreasing, and finally 0. So during this whole journey, at various points its speed at that particular moment could be different. So that is called instantaneous speed. Understood? Whenever the person just look at the speedometer and the speed is indicating say 30 km per hour, so that is the instantaneous speed of that particular moment. Okay, so you can say average speed is delta x upon delta t. Okay, delta x is distance covered and delta t is time interval. So here the rate of change of position, rate of change of distance with respect to time. If you are decreasing this time interval delta t, then whatever the speed you are getting, whatever the change you are getting, that is very small. You can call it instantaneous rate of change. Okay, let me explain you the differentiation with a very simple example. Say this, suppose I'll say x is equals to 4t square. X is a function of time, x is distance covered and t is time. Say x is distance and t is equals to time. Okay, I want to find rate of change of x in time t. So let us say in time delta t, the extra distance covered is delta x. So in total time t plus delta t, distance covered is equals to x plus delta x. Understood? Here x is what? X is function of time, x is function of t. Okay, so from this function, instead of x, if you suppose substitute x plus delta x, okay, and instead of t, I should say t plus delta t. So 4 into t plus delta t whole square. Now t plus delta t whole square, you can solve it by a plus b whole square. This is x plus delta x, 4 into bracket a square means t square plus 2ab. So 2t into delta t plus delta t square. Okay, now multiply 4 to each. 4t square, 4 to the 8t delta t and 4 delta t square. This is x plus delta x. Understood? Instead of x, you can write 4t square. Here x and 4t square are same, so you can cut x and 4t square. Now, delta x is equals to 8t delta t plus 4 delta t whole square. I want to find rate of change, which is delta x upon delta t. I have value of delta x, I'll divide by delta t each. Delta t, and delta t. And my answer, delta x upon delta t is 8t plus 4 delta t. See this. Delta t cut, 1 delta t cut. So answer is 8t plus 4 delta t for delta x upon delta t. Change in distance with respect to time is this formula. Okay. Now, moving further. See, I hope you people are making notes with this. For this delta x upon delta t. Now we are moving to differentiation. Okay. Differentiation is what? For this delta x upon delta t, when I write 8t plus 4 delta t, what if delta t limit tends to 0? This limit tends to 0 means delta t is extremely small. You can take the time interval is 0.0001 second or 2 seconds, right? So when the time interval is very small, instead of delta, you can write d. But before that, this delta t tends to 0. You can substitute 0 over here. So here delta x upon delta t, extremely small. That is 8t. Now this can be written as dx upon dt is 8t. Okay, dx upon dt is what? 8t. This is your answer. But every time you don't need to do this all thing, this whole derivation and this dx by dt is 8t. I'll give you a simple formula. With the use of that, you can solve differentiation. Right now I'm explaining this delta x upon delta t is average velocity. This is called instantaneous velocity. Okay, so this is dx upon dt for extremely small interval time. Dt is extremely small interval time. So dx upon dt is called instantaneous velocity. Understood? Okay, let me take you one more example. Okay, I'm clearing this out. Fine. Suppose, say x is equals to t cube. New question. Suppose x is equals to t cube. Take it as t cube. Now x is changing with respect to time, and for x proportional to this t raised to 3 t cube. So for this x plus delta x is equals to 4 Oh, I should write this. T plus delta t whole cube. I hope you people remember this. A plus b whole cube is a cube plus b cube plus 3ab, a plus b. Instead of a, you can write a, instead of b, delta t. So x plus delta x is this t cube plus delta t cube plus 3 t into delta t into bracket t plus delta t. Okay, very simple basic mathematics formula. So therefore x plus delta x is equals to t cube plus delta t whole cube. Now this plus 3t square delta t plus 3t into delta t square. Okay, but I want to find delta x upon delta t, rate of change of x with respect to time. See, this x and t cube are same, x equal to t cube, you can cut this. Now delta x will become delta t cube plus 3t square delta t plus 3t delta t whole square. Now divide each and every term by delta t. So delta t, delta t, delta t, and again delta t. I will get this delta t square plus 3t square plus 3t into delta t only. For this, delta t square plus 3t square plus 3t into delta t. When delta t limit tends to 0, when delta t is extremely small, say 0.001, 0.002, extremely small, then you can neglect delta t over here. So this will become dx upon dt. Delta in jagya d kari dido. So your answer will become 3t square. This will become 0. This is also 0. So answer is 3t square. Okay. So this is the basic fundamental of differentiation, that we are going to discuss the rate of change with respect to time or with respect to any other quantity. Okay. But for extremely small interval. Fine. So let me just remove all this. For xt cube, the answer of dx by dt is, we have solved two questions. First was x is equals to 4t square, dx by dt was 8t. Second is x is equals to t cube, dx upon dt is 3t square. Now again, as I told you, you don't need to perform all this. Okay, we are not going to follow this in each and every question, where we need to find the change, where we need to find the instantaneous rate of change. So let me just cancel out and giving you a small equation, just a formula. See this, for differentiation, if x is equals to t raised to n, if x is equals to t raised to n, this is most important formula, dx upon dt will become n into t raised to n minus 1. Okay, this is the formula. This you need to remember only. X is equals to t raised to n is equals to n t raised to n minus 1. Okay, let me apply this formula to question number 2. x is equals to t cube instead of n. Here 3 is there. For x is equals to t cube, your n is 3. Okay. Here 3 t, 3 minus 1, 3t square dx upon dt. This was dx upon dt. Okay. Is this your answer? Fine. Let me apply the formula for this. This was the second question. Now, suppose x is equals to 4t square. See, 4 is a constant which is coefficient of t square. 4 is not going to change. So, I will keep 4 as it is. For dx upon dt, d upon dt of 4 into t square. See, if a constant is coefficient of the t square, t cube, whatever it is, just take it out of the differentiation. You can write 4 into d upon dt t square. So what will be your answer? Instead of n here 2, to take 2 over here, your answer will be 4 into 2 t raised to 2 minus 1. Very simple. N t raised to n minus 1. Instead of n here 2, 4 into 2 which is 8. T 2 minus 1, that is 1. So here is the answer, 8t. Okay, you can solve number of questions with the use of the simple formula. Let me solve 5 questions. Okay, right now 5 different questions with the use of this formula. Say first x is equals to 8t raised to 5. Second, say x is equals to 7t raised to 9. Third, x is equals to t raised to 100. Fourth, x is equals to 5t square. And fifth, x is equals to 4. Okay. So now, with 8t raised to 5, 8 is your constant number. You don't need to differentiate constant number when it is coefficient of function of t. So just a circle. Now dx upon dt, what is your n? Very simple. Okay. Instead of n, 5 is there. So I can write 8 d t raised to 5 upon dt. Don't cut this d and d, huh? This is the symbol. What was over here? I forgot. Write new question. 7 x raised to 9. Or say. Now, my answer is 8 as it is. 5 into 5. 5 minus 1. T raised to n minus 1. My answer will become t raised to 5 minus 1. 40 t raised to 4. This is your answer. Very simple. For this, x is equals to 7x raised to 9. Dx upon dt, differentiation of x with respect to t. 7 as it is. Instead of n, 9 is there. 7 into 9. X raised, here t. T raised to 9 minus 1. My answer is 63 t raised to 8. Instead of n, in the third question, 100 is there. Here is my answer, dx upon dt is 100 t raised to 100 minus 1, which is 100 t raised to 99. Easy? Okay. This question, dx upon dt, 5 as it is, 2. Okay, 5 into 2. Check that t is equals to 2 over here. N is equals to 2 over here. 2 minus 1. 10 into t. Finish. Now, x is equals to 4. Say constant number is not changing when it is alone. Here 8 is function of x is function of time and 8 is coefficient of t. But when this only constant number is there, you can write dx upon dt of any constant number, that will become 0. How? Let me explain. Say this. I can write x is equals to 4 into t raised to 0. T raised to 0 is 1. T raised to 0 is what? 1. Any variable raised to 0, that is 1. So I will write 4 into 0, this dx upon dt, 4 into 0 minus whatever it is. 4 into 0, your answer is 0. So always remember these things in your mind. When constant number is given, only constant number, not coefficient of t, only constant number is given, its differentiation will become 0. Understood? Okay. So this is the main formula for differentiation. Okay. I can explain you on the basis of graph also, but that I am going to explain when you solve the coordinate geometry, basic coordinate geometry. Okay. So here is your formula, final formula. For differentiation. Okay. If x is equals to a into t raised to n, where a is constant, t is variable, and n is power of t. Differentiation dx upon dt, that will become a as it is, n t raised to n minus 1. Understood? This is what n into t raised to n minus 1. This is your final formula for differentiation of x raised to, t raised to a t raised to n. Understood? You can solve any of the question with the use of this formula. This is correct. This formula is correct for addition rule and subtraction rule also. Not correct for multiplication rule and division rule, that we are going to study in our next lectures. Correct for addition. Okay. How to do differentiation for this? Suppose x is equals to 3t cube plus 4t square plus 5. X is function of t, and I need to differentiate this dx upon dt. So I'll write d by dt of 3t cube plus 4t square plus 5. Now I'll apply differentiation to each and every term. Okay, so 3 is constant, d upon dt of t cube plus 4 constant, d upon, that's why outside the differentiation, t square. Here d by dt of only 5. See, 5 is a constant number. Differentiation of a constant, only constant, lonely constant, you can say 0. Okay. Now 3 as it is. Instead of n, we have 3. So n t raised to n minus 1, I can write into 3 t raised to 3 minus 1, then plus 4 as it is. Instead of n, we have 2, so into 2 t raised to 2 minus 1, and 5 is a constant number, only constant number, so 0 is your answer of differentiation. 3 3s are 9, t square 8t. Final answer of dx upon dt. Okay, dx upon dt is what? 9t square plus 8t. Understood? Fine. Okay. Write down this. One more question on the basis of this. Say x is equals to 5t cube minus 4t square plus 8. Okay. So this is 3 dx upon dt. D by dt of this 5t cube minus 4t square plus 8. I was talking about this. This is 3. Instead of n, we have 3 over here. But one by one, d by dt of this 5t square minus d by dt of 4t square plus d by dt of 8. Here constant term 5 is out of differentiation. You can write directly like this also. D by dt of t square, t cube it is, t cube minus 4 outside, d by dt of t square, and this is a constant term. 8 is a constant term, its differentiation is 0. So differentiation of t cube 5, this 3 into t raised to 3 minus 1 minus 4, 2 into t raised to 2 minus 1. So answer is 5 3s are 15 t square, 4 2s are 8 t. This is your final answer. Okay, understood? So this is the basic derivation, basic differentiation formula. I am going to list out few more formula for differentiation which you need to remember. Okay, which you need to remember, and we are going to solve numerical on the basis of those formula by tomorrow. I hope you people are making notes with this. Okay. The first formula which we learned today, that is d by dt of t raised to n is n t raised to n minus 1. The next formula, d upon dt a into t raised to n. A is a constant. You can write a t raised to n d upon dt, and then your final answer will be a n t raised to n minus 1. Then new formula for differentiation, d upon dt of a, where a is a constant, answer will be 0. Okay. So next formula is d by dx of sin x. Oh, sorry. See, this is in the form of variable t. You can write this also, d by dx of x raised to n. Can be written as n x raised to n minus 1. See, instead of t, I have written x. The function is changing with respect to x. Same, d by dx of ax raised to n. Your answer will become an x raised to n minus 1. Here differentiation was with respect to t. Here differentiation is with respect to x. Okay, d by dx of constant term 0. Okay, understood? Fine. Now d by dx of sin x, which is cos x, d by dx of cos x, which is minus sin x. Okay, you need to remember this. D by dx of tan x, which is sec square x, d by dx of cosec x, which is minus cot x, and last d by dx of cot x, which is minus cosec square x. Here each of them is function of x and I am differentiating with respect to x only. See this? Okay. If you write d by dt of sin t, here you can write cos t. Understood? D by dt of this cos t, it will become minus sin t. Instead of x, you need to write everywhere t. If it is y, then d by dy of sin y, cos y. Okay. So these are the function. But let me just give you a simple hint how to remember this. Those functions which are starting from c, 1, 2 and 3, in all three differentiation you will get negative sign. Differentiation of sine is cos, differentiation of tan is sec square, differentiation of this cos x is minus sin x, differentiation of cosec x is minus cot x, differentiation of cot x is minus cosec square x. Okay, so I forgot to write the differentiation of sec x. Okay, d by dx of sec x is sec x into tan x, sec x into tan x. This is wrong, huh? This is, sorry, minus cosec x into cosec x. Okay, minus cosec x into cot x. I have corrected this. D by dx of sec x is sec x into tan x, and d by dx of cosec x is minus cosec x into cot x. Okay, you just need to remember all this formula. Right now few formulas are given on your screen, right? You just get a screenshot of it and remember all this formula. Fine. So in today's lecture, this was some basic differentiation. It was purely basic differentiation, purely rate of change. In very much detail, we are going to discuss the differentiation, the product rules in our next lecture. So stay home, stay safe, stay tuned. Bye.